Hey, Mr. Wilford here, and I was just going to go through Chapter 5, Section 2 today, Properties of Quadratic Functions in Standard Form. And we just wanted to kind of cover a little bit some of the different properties and pieces of our parabola that we talked about in the first section. There are a few important pieces that we want to take a look at here uh, in terms of the graph. So the first thing that we'll take a look at is something called the axis of symmetry. The axis of symmetry is a vertical line that goes through the vertex. If you remember in section 1 we talked about the vertex of a parabola being the maximum or the minimum point. And when you take this vertical line and you slice that parabola in half, that is called the axis or line of symmetry. Um, and we can find the axis of symmetry if you have your quadratic function in this form right here. It's actually x equals h. H is when you have x equals a number, that indicates a vertical line, and you can see here that h is the x coordinate of our vertex. Now, one of the things that we want to use, probably most common, is something called the standard form of a quadratic. And this is important because we'll talk about standard forms of polynomials and other types of equations. When we talk about the standard form, what we are looking at is a function or an equation that looks like this. F of x equals, and it's important to have our x squared term first, then our x term, and then our constant. And when we have our parabola, our quadratic equation here in standard form, we can talk about a lot of the things that we've kind of mentioned a little bit and actually come up with equations for them. First of all, the parabola, you can tell if the parabola opens up or down just by looking at your a, the a value, which is right here, the number with your x squared. If a is greater than 0, in other words, if it's positive, your parabola is going to open up. If a is less than 0, in other words, if a is negative, the parabola actually is going to open down. So that's one quick thing you can look at. The axis of symmetry we just talked about, and there's another equation for that, and this is the more common one right here that you'll see. X equals a negative b over 2a. And again, remember, the axis of symmetry is a vertical line, and if you have your equation in standard form, you're going to take your negative of b, in other words, the opposite of b, and you're going to divide it by 2 over, or divide it by 2 times a. And then your vertex point, once you have your x vertical line here, what you're going to do is you're going to take that number and plug it in for x here and here, and then you'll get your y, and you'll actually create your vertex point. So you'll be able to find that maximum or minimum point. And then finally, if your equation is in standard form, then your y-intercept will be the c. So that constant number will tell you where your parabola is going to hit the y-axis. Standard form is when the quadratic equation is set equal to y. And again, we want to have the x squared, then the x, then the constant in that order. And again, we can talk about the vertex point. We can have a minimum value and we can have a maximum value. So when we have our parabola opening up, we're going to have a minimum value, and this minimum value will be this vertex point hk. And we also want to talk about domain and range. Domain will always be real numbers, whether we have a maximum point or a minimum point. And the range depends on if it opens up or down. If it opens up, then our range will be numbers greater than or equal to the k value of our vertex. If it opens down, it will be range will be y values less than or equal to our k value. And that's about it. If you have any questions, please let me know. Thanks.